Nernst equation, electrode and cell potentials. This is very important equation. You should know how to write the Nernst equation for a given cell reaction. Okay, we will see the variation of the electrode and cell potentials with concentration of the ions. Nernst equation especially, it connects with concentration of ions in solution is given by Nernst equation. Okay, just we will see now. We have assumed in the previous section that the concentration of all the species involved in the electrode reaction is the unity. This need not to be always true. Nernst showed that for electrode equation. Okay, what Nernst showed, this is the ion, metal ion plus number of electrons gives rise to metal solid. This is one reaction. Reduction takes place here because the addition of electrons to the metal ions is called it is a reduction. The electrode potential at any concentration measured with respect to the standard hydrogen electrode can be represented by the electrode potential at any concentration measured with respect to the standard hydrogen electrode can be represented by, this is the equation. This is very important. How to write is very important. It is Nernst equation. This is the electrode potential. Students, this difference between E and E naught is very important here. E is the electrode potential and E naught is the standard electrode potential. This is the difference. This is the electrode potential and this one E naught is standard electrode potential. Clear? So electrode potential equal to standard electrode potential or standard reduction potential minus RT by NF ln, okay, logarithm with base E. Ln represents m right hand side, m by n, mn plus. So right hand side whatever the product by left hand side metal ion. Clear? But concentration of solid m is taken as unity. Concentration of the solid, it is taken as unity, means 1. This value it becomes 1. Then we have, this is the relation now. So concentration of m equal to 1. This is the relation. So E naught mn plus m has already been defined. E naught is the standard electrode potential. Standard electrode potential has already been defined. R is a gas constant 8.314 joule per Kelvin per mole. F is Faraday's constant 96,000, approximately 96,500 coulomb per mole. T is temperature in Kelvin and this is the concentration of the species. Square represents concentration of the species. This is very important. Concentration of the solid is taken as unity 1. Clear? Now we will see what will happen. Next, in Daniell cell, the electrode potential for any given concentration of copper 2 plus and zinc 2 plus ions we write. For cathode and anode already we discussed what is Daniell cell and the reactions which are taking place in Daniell cell. Okay, copper or cathode, at cathode reduction takes place, Cu2 plus 2 electrons gives rise to the Cu solid. That is the reaction which is going to take place at cathode. Already we discussed at that point. At anode also we discussed oxidation takes place, zinc gives rise to zinc 2 plus 2 electrons. And a net reaction, what is our net reaction? You can go back and check the Daniell cell once. Net reaction we will get zinc plus, just I will write to, this is the net reaction, zinc plus copper 2 plus copper 2 plus gives rise to copper plus zinc 2 plus zinc plus 2. Okay, this is the reaction. Generally this is the cell reaction, Daniell cell reaction. Zinc plus copper 2 plus gives rise to the copper plus zinc 2 plus. Clear? So finally students, I would like to show you directly how to write is very important. Yeah, first for cathode what will happen directly, Cu2 plus 2 electrons gives rise to the C. This is the cathode reaction. So E of the cathode Cu2 plus Cu couple E naught minus RT by NF. Earlier slide I have discussed NF. How many electrons here? N equal to 2. So ln of copper by copper 2 plus, that means Cu by Cu2 plus. You have to look at here to here only, copper 2 plus to copper only, because this is the only reaction which takes place at cathode. So at cathode we are discussing now. So at cathode only Cu 2 plus to the Cu. So Cu value, it is solid Cu, so value taken as unity 1 by Cu2 plus. For anode, this is the reaction at anode again, N value 2. Clear? So cell potential E cell equal to E copper couple minus E, in the sense E cathode minus E anode. Okay, so after some calculation we will get this one. This is very important, how to write. So finally this is the cell reaction, Daniell cell reaction. Okay, spontaneous reaction. For this reaction, this is the equation, Nernst equation. E cell equal to E naught cell minus RT by NF, or here 2 electrons. How many electrons transferring? 2 electrons. Ln means log of E, natural logarithm. Right hand side, always focus on right hand side. Zinc 2 plus and copper 2 are present. So zinc 2 plus into copper, actually zinc 2 plus into copper, but copper it is a solid, no charge, so copper is a solid, so concentration is taken as UT, means only 1. So zinc 2 plus into 1, we no need to mention here. Similarly by left hand side part, zinc here solid, it is a solid, so it is taken as unity. Again take copper 2 plus. So only focus at ions only. So we are supposed to take ions only, not the metals, because the value of the metals should be unity. Clear? So how to write is very important. Yeah, it can be seen that E depends on the concentration of the both Cu2 plus and zinc 2 plus ions. Earlier we have studied, because focus at only ions only. It increases with increasing the concentration of Cu2 plus ions and decreases in the concentration of the Zn2 plus ions. Means E naught E depends on exclusively the cell potential. Standard electrode potential nahi hai idhar. Okay, this is the electrode potential or cell potential. It depends on the concentration of both ions. Clear? Next, by converting the natural logarithm in equation 3.11 to the base 10, because whatever I have used earlier, that is natural logarithm, means ln or log base e, log base e. So now we are converting that natural logarithm into the base 10 and substitute the values of the R value, universal gas constant, Faraday 96,500, T 298 K, room temperature. Then this is the final one, E equal to E naught cell minus, here RT by NF we have seen earlier, but after substitution, what is the final value? 0.059 by N. Okay, 0.059 by N. Remember this value, you no need to again calculate, just fix this number, remember this number, 0.059 by N. Again log, here base 10, log of base 10, zinc 2 plus copper 2 plus. Okay, we should use the same number of electrons for the both the electrodes and thus for the following cell. This is the one more reaction, nickel 2 plus and Ag plus Ag. How to write this? First write the cell reaction. Okay, first write the cell reaction. Nickel to the nickel 2 plus means nickel to the nickel 2 plus, 2 electrons change, 2 Ag to the Ag. Already I explained you how to write the net cell reaction. You should know how to write the net cell reaction. Okay, that is very important. So after writing the net cell reaction, then only we can identify the number of electrons are involving here. Clear? So here how many electrons are involving? Only 2 electrons again. So E cell equal to E naught cell minus RT by 2F ln Ni 2 plus Ag plus square, because here 2 times is there, so square. Okay, this is the general equation. AA plus BB n electrons, CC plus DD. Nernst equation can be written as E cell E naught cell minus RT by NF. It is better to just remember 0.059. This is 0.059. You will get this. Yes, put the value of R, T and F, then you will get 0.059 log base 10 value. So how to write means right hand side C, how many times C, D present, D times power D by A present, coefficient here power A again B power B. This is the general equation and this is the procedure how to write. How to write Nernst equation for the given reaction, that is very, very important. Yeah, one problem is here. Now we will see. Always remember the how to you should know how to write Nernst equation. Clear? Okay, check the question. Represent the cell in which the following reaction takes place. Mg plus 2Az plus bracket 0.0001 m concentration is given here. Clear? Mg2 plus again concentration mentioned and plus 2Az. Az is the solid, means value unity 1, and magnesium is the solid, again unity 1. Remember. Clear? Calculate its E cell, not E naught. E naught is different. E cell, if E naught cell equal to 3.17 volt. Okay, so this type of reaction, when you see this type of reaction, bracket mein some numbers are there, concentration, immediately you are supposed to write Nernst equation. Clear? So then this is the Nernst equation. E cell equal to E naught cell minus RT by NF, or RT by F. It is better to substitute this one 0.059 directly. RT by F, this value, exactly this value, RT by F means 0.059 you will get. Remember this value. Log of, here log of Mg2 plus, right hand side Mg2 plus is present and Ag silver is present, but silver solid, no need to take Mg2 plus, by again left hand side magnesium solid is present, so don't take, and again Ag plus, Ag, take the Ag plus. At the same time, how many Ag plus are present? 2. That means Ag plus square. This is very, very important. Most of the students, you people miss here only. Clear? How many times is very, very important. Here 2 times is present, but no need. 1 square equal to again 1. But here there is no 2. Only single time. But here concentration Ag plus. How many times? 2 times. So Ag plus square, Ag plus concentration square is very, very important. This is the main thing here. Clear? Substitute the values. E naught is given 3.17 and 0.059. Again I am telling you RT by F into ln log 2.303 we will multiply. It is, remember always, 0.059 by number of electrons to log of Mg2 plus value is given 0.130 by Ag plus 0.0001 square. This is the answer, final answer. Yeah, next, equilibrium constant from Nernst equation. Clear? So I don't want to discuss all the data. Clear? Directly, this is very, very important for your exams only. This one, you go through the what is given here, you can understand. So just I would like to mention this point only. So the relation between equilibrium constant and E naught or EM, standard electrode potential, is given by E naught cell equal to 2.303 RT by NF log Kc. This is the relation. This relation is very, very important. So again I am telling you 2.303 RT by F, this value 2.303 RT by F, this is equal to 0.059. Always remember, directly mention E naught equal to 0.059 by N log Kc. Okay, easily you can solve the question. Next question. Calculate the equilibrium constant of the reaction Cu plus 2Az plus gives rise to Cu2 plus 2Az. E naught is given here. Solution first. We know the relation between the equilibrium constant and standard electrode potential of the cell. So E naught cell equal to 0.059 by n log Kc. This is the formula. Okay. So just I will, actually 0.059 by n is the formula. But n equal to how many electrons are? Again I will show you. How many electrons are involving here? Copper to copper, copper 2 plus 2 electrons. So take the 2 log Kc. This is equal to 0.46. Now log Kc, just calculate. You will get Kc equal to 3.92 into 10 power 15. Next one, the relation between standard Gibbs energy and equilibrium constant. This is the relation. So delta G equal to standard Gibbs energy, delta G naught equal to minus RT ln K, natural logarithm base E, log E base. Ln always represents a log. What is the base? Yes, log with the base E. Clear? Okay students, thank you for watching my video.